La siguiente conferencia está a cargo de Ryan Price y Peter Windmoller de Airstream, quien nos hablará sobre la tecnología para el mejoramiento de ventiladores que se usan en la solución de la industria del cemento.
Está bien, es la segunda vez ahora. Está bien. Gracias. Okay, good afternoon, everybody. My name is Peter Windmuller. I'm a representative for the Canadian company Airstream, an engineering company that focuses on fan upgrades. So we are not an OEM. We are not interested in the first fan in the plant. We are interested in the upgrade of the second or third or fourth impeller when you start to see problems. So kiln upgrades or upgrades in the process may have many, many reasons. There are two large areas. One is a classic shareholder-oriented value. You want to increase performance, you want to lower production costs, you want to maximize the output of the plant. In recent years, we have seen another motivation, which is coming from the society, environmental awareness, part just from an ethical point of view. We all have children. We all understand that we cannot continue many processes as we did in the past. In other ways, it is not only ethical, it is also legal. The plants meet the standards or have to meet the new standards imposed by the governments. We have heard this morning or yesterday presentations about mercury and other emissions. So there are many changes that are forced upon the cement plant that cause changes in the process to improve it and to reduce emissions. Obviously, as you know, the main fans in the plant are the baghouse fan, the kiln ID fan, the raw mill fan, finish mill fans, and cooler vent fans. To some extent, we have the undergrade cooler fans. In our case, we say those are small catalog type fans, but as we have seen also here today, sometimes when plants are upgraded, the coolers need more air, so those are interesting fans, can be interesting fans. And many of the plants are older, and after 10 or 15 years, there have been so many changes that nobody really knows what's going on. We all have a control room screenshot, we all have some measurements, but what really is the resistance in the fan between inlet and outlet? There have been so many changes that the original fan curve very often does not apply anymore. So those projects are driven by costs, as I've explained, ongoing maintenance costs, operating costs, and the initial capital investment. If we look at the reduced maintenance costs, those are very important, especially in the markets where we are in sold-out situations. And maintenance due to a fan buildup or in the fan for kiln ID fans, for example, causes an additional shutdown. Those can be very expensive maintenance costs. In addition, generally you have the regular annual repair costs in the dirty air applications, the mill fans and the kiln ID fans, preheater fans mainly. Baghouse fans or ESP fans generally require significantly less maintenance. The approach with an upgrade usually allows us to reduce those costs by eliminating the buildup, thus eliminating the chance that you have vibrations as your production campaign continues and the buildup increases, and at some point the vibration sensors say, I'm at the limit, we have to stop. We also see a longer wear life in those fans due to the design, which allows them to be replaced less frequently. So not only do you have a longer wear life, you also have lower costs because every large rotor replacement is a significant maintenance job. Operating cost benefits. This is a little bit a slide for the salespeople. I have to tell you that you cannot add 30% plus 25%. Those come from general efficiency increases that we can achieve by redesigning the impeller. So if we have a general, let's agree on 25% efficiency increase, it ranges from 15 to 30. If we have an efficiency increase, it is up to the plant to decide, I would like to reduce my kilowatt consumption. This is a situation we see very frequently in the US, where everybody says, I have enough capacity, I'm good, just give me the savings on the energy. Whereas in South America, we have more situations where the plants are in a sold-out market, and they say, energy saving is great, but I don't want it at the fan. Give me more performance for the fan, and my energy saving will be on the overall kilowatt per clinker ratio. So those are the decisions that the plant have to make. And because of those generally large efficiency increases, the payback usually is very fast. If the payback is only based on kilowatt, can be up to 18 or 24 months. And of course, if we can increase the production, the payback usually is below 1 year. It is not only a case of production increase. I've recently run into a plant where we said, we don't need more clinker, but our corporate office requires us to increase the alternative fuels usage. We are now at 15%. In 2 years, we need to be at 30%. But we are fan limited. So the fan is preventing this. So in this case, we're able to provide additional benefit by allowing the plant to increase the alternative fuels rate without necessarily increasing the clinker production. Capital costs, I have put this at the last place because basically when you have decided that you are looking at a fan upgrade, the decision is made. The plant has understood that there is a problem either on the wear or on the buildup or on the performance in the fan, and that this has to be solved. So what we are really talking about is the difference between an improved fan impeller, that's right. The difference between an improved impeller, where we exchange the rotating part, the rotor, the shaft, and the inlet cones, and a replacement from the OEM in kind. So they know the wear will be good for another year or 2 years, but there's no real process improvement. That's why I have it here at last. The approach with an upgrade usually is a little bit more expensive because there's a lot of engineering that goes into the redesigning, but because of the added benefits, the payback is definitely there, and in reality, you just have to compare the in-kind replacement, so same, which is, let's say, 100, versus a new design of the impeller, which is whatever the number is, 110 or 150, it doesn't matter. So basically, your added value just goes against that payback. 2 case studies. This is a cement plant in a Canadian company, in a cement company, relatively independent, does not belong to one of the large groups. They have spent a lot of money in a complete upgrade of the preheater tower and looked at more fan performance in this case to achieve process improvements they have from the large benefit. This is a situation we came into, and the original fan supplier said, we cannot do this, you have to buy a complete new fan. So the task was basically to increase efficiency, which was luckily for us extremely low in this case, 50% is extremely low. To reduce the maintenance, to eliminate annual impeller replacements. That was a big problem, not only money, but also time and effort. And as I've said, the plant was looking for an alternative for the complete solution, because the complete solution usually does not only replace your housing and the fan, but it's a much more complex project. the interfaces, the ducting, the dampers, possibly the motor have to be enlarged. If your cabling is not big enough, you have to replace the whole cabling motor control unit. So this simple fan problem all of a sudden becomes a major project in the plant. What was the result? A redesign using the customer's motor, the customer's foundation, the customer's housing, allowed the plant to achieve all of the tasks or the objectives that were set out. And you can see here the performance or the savings plus this is well above 25%. This is because we were lucky in this situation. The situation to start with was an extremely inefficient fan. So this is why you have the combination here, which is significantly larger than the 25% I had mentioned before. There was no wear after almost 2 years, and the annual repairs were basically eliminated and reduced to a standard visual inspection and cleaning. A second case study is a raw mill fan. You can also see it's a sizable fan. This was a fairly new plant in Florida, and the impeller was replaced because there were frequent shutdowns required to clean the fan during the production. And this project is actually an older project. It was established in 2008, I believe. So this was a time when in the US the economy was booming and every additional shutdown was real money. So they couldn't afford or didn't want to go through those additional costs and production stoppages anymore. And you can see the point that we achieved in this. We had worked with a different plant of the customer on several smaller plants, so they knew our approach. They wanted energy savings, of course. The original fan was showing a lot of wear because it was constructed too light. And we were asked to evaluate the fan and propose a project. You can see here the original fan only had partial liners. One of the problems, a lot of wear. Fan pressure did not meet the original specification. It's a very common project or very common problem. When Airstream goes in, we conduct our own tests. So we work with the plant initially on a theoretical basis, but once the project has gained the interest and the plant says, yes, we would like to go deeper, we will come in and we will perform our own testing to really see what is happening inside this fan. This was a result. The original performance could be restored. Compared to that, power savings were significant. If you put this into percentage, we are not at 20%, but we are close. Plus, we have this additional performance increase. No more shutdowns during the regular 11.5 months campaign. And economical project cost, because only the impeller, the shaft, and the inlet cones were replaced. So basically, we're talking about a standard impeller replacement plus minor on-site modifications of the housing. But none of those require significant work. And the design is done in the way that the new inlet cones will match the old housing, including tolerance adjustments. So summing up, the presentation is supposed to offer to you that there is an alternative to just replacing fans. The complete fan replacement is a large project, and a further upgrade can reduce this. Maintenance costs for sure will be lower. We have at least twice the wear life than other fans. Dust buildup is reduced to the point where we don't expect any stoppages due to vibrations. performance increases up to 20%. Again, it's either performance increase or savings. We cannot give both. And due to that, projects usually show a very fast payback, meaning 1 year or less. If you have any questions, I'm available. Thank you very much. And again, thank you for translation.